Welcome to the first presentation from the Information Systems and Semantics series, providing a quick introduction to RDF. In this presentation, I will briefly explain the motivation for using RDF. Then we will go through the basics of RDF specification and principles. Afterwards, we will see how RDF can be represented using various formats. And to conclude, I will include some use cases where RDF can be used and how. To bring a bit of a background that might be well known for you, we use models in information systems to describe the reality or domain that the system should support. It provides structure for storing information, such as database schemas or data classes, and also models some semantics or meaning for the underlying data. Data or instances are expressed using a model. For example, in this case, that Marek as a person has name Marek, some string value. And this can be done because we have some model expressed using some language, or more precisely meta model. In this case, saying that person is a class and has property name. We could use, of course, a different meta model, for instance, saying that person is a data element and has some field name. As we have seen on the previous slide, we made some simple statements, and that is actually how to capture some semantics in the most versatile form. Here on this slide we have another example, which is from the very basic word books in Czech education, when kids are starting to learn how to read, and it says Eve's minces meat. We can see that it has three parts: subject, predicate, and then object, which is really simple, but as we will see later on, it's really versatile and flexible. And such a semantic triple consists of these three elements and is actually a basis of RDF. We can also capture such a statement or semantic triple as a graph where subjects and objects are nodes, and the predicate forms some oriented edge between these two nodes. As it is evident from this statement, the direction really matters, because we, in this case, wouldn't want to model that meat minces Eve, and this is something that you need to always take care of, that the order matters. If we have statements as graphs, we can then connect them together via the nodes. For instance, if we connect it with statement that Eve is a woman, we can then use the graph to search for information. For example, asking if there is any woman mincing meat, how many such women are there, etc. When we have RDF statements or triples represented as a graph, we can also create some subgraphs or named graphs when we are having some statements in a specific context. For example, here we state that Eve minces meat and that Eve is a woman in the context of my example context. This is denoted by the dashed ellipses to denote that this is just my example, for example, for this presentation. And what I'm able to do then is that I can make statements about this context, about this subgraph, as it would be a node. Here we talked about semantic triples, but when we are adding this fourth information, it is sometimes called quads or quadruples. So we went through the motivation and finally are getting to what actually RDF is. It is a resource description framework, It is important. It is not a language, not a model, but framework. And mainly it is W3C specification, which was originally developed as metadata model, but it is so versatile that it's applicable to practically anything, as we will also see in practical use cases later on. It states how to describe resources in this versatile, flexible way using these semantic triples or quads, and it is the main component of semantic web. And actually you can take a look at the specification. Here is a link for primer of version 1.1, and actually there is version 1.2 coming up these days. Here we can see the stack of semantic web technologies, and RDF is at its very core or basis. RDF itself is syntax agnostic. We will get to different formats, one of which can be XML representation, but later on we will also get to the layers above. For example, how to model or how to query some RDF statements, and what are the benefits of that. But now let's stick with RDF and let's take a look what types of resources can we describe or use in the RDF graphs. So actually, what is a resource? RDF specification says that it's something in the world, the universe of discourse, including physical things, documents, abstract context, numbers, strings. So basically anything can be a resource and anything can be described using this framework. So it states that the framework is so flexible that it can be used to describe practically anything. We distinguish two types of resources. So something that is complex and has an identifier, then it's a referent. Or we can have something simple, some value that is expressed as a literal. So we have literal value. These reference literals and something called blank nodes can be used as nodes in a graph. So previously on some slides we saw some graphs. For example, Eve, meat. We have also the node for woman. And these nodes can be reference, these nodes can be literals, and those can be also blank nodes. That is something that we will go through later on. So what are reference and how we can make some identifiers for them? So you maybe know URL. URL is Uniform Resource Locator. It can look, for example, like this. So some protocol, some domain, and some path. And then there is something called Uniform Resource Identifier, and that leads to a specific resource within some location. So we have the location, the locator, and then we can have some specific resource there, and this is, for example, the identifier of resource Marek Suchanek, which is me, in this location. Maybe you know that these URLs and also uniform resource identifiers can use only a subset of ASCII. Otherwise, you need to use the % encoding, as it's now visible in the example, where I use my actual name with accent. So Suchanek has an accent over A, and you can see that this leads to some % encoding in this form. So therefore, in RDF it is recommended to use these internationalized resource identifiers that can use these extended characters from Unicode. You can see that still some special characters like spaces needs to be percent encoded. So we can see that these uniform resource identifiers or internationalized resource identifiers are something to identify resources that can be described in RDF, making them reference. The other type of resources are literals, and literals are used for values such as strings, numbers, dates, floating numbers, etc. Each literal in RDF or in an RDF graph consists of 2 or 3 elements. First, there is the lexical form, some Unicode string. So you can write, for example, Marek or 15, but you need to write it as a string. That's important. Then there is data type. Data type is again a resource itself. So data type is identified by resource identifier. In some formats you can write it like this, that you specify that the literal, now 15, is of type of certain identifier. In this case it's integer from XML schema. And last element is language tag, and that can be used if and only if the literal is language string, and we can specify it to denote the language of that string. So for example, we can say that this string Marek is in Czech language using this ISO code of Czech language. When we are using literals, there are some implicit expectations. So if you do not specify explicitly the data type, it is a plain string. If you specify just the language tag, then it expects a language string to be used there. And now we are finally coming to the blank nodes that I mentioned a few slides earlier. And blank node is a node in RDF graph that is not a referent and also not any literal. So it's something that does not have some identifier. It can have some just local identifier in a file or in a database. But we do not use this identifier to refer to it from outside. And in this example, we can clearly see what it can be. So for example, here we have O'Reilly headquarters residing on some address. And the address is composed of different parts. So for example, some city, some state, some postal code, and some street address. And this information together needs to be like glued together, and it's done using this blank node. But we do not need any identifier for the address as it is. We just need to know its parts. So we use this blank node. So we covered what are the resources and how we can describe them in RDF using semantic triples. But we obviously need to know how to actually write them and to read the triples from some formats. And there is a number of such formats defined by W3C. Each has its own specification, and also each have its own advantages and disadvantages. For example, some are more human readable and understandable, some are more efficient for parsing, and some can be better for interoperability with some legacy systems. And also some of the formats support these quotes that we talked about, providing the fourth information for the context. So now we will cover just the most widely used to give you an overview of these formats. The first one is the XML format, and what can you see in the example are custom XML tags with RDF1 on the top level, and each of these tags uses some prefix. Those prefixes are defined in the opening RDF tag, as you can see, with some URL prefix. And we can see these prefixes RDF, measure, example, and base there. And then we have a tag that describes a node, or more precisely a resource Eve, with two statements inside, is minting, and is minting some blank node that's denoted with A. And then that Eve has name Eve as a string value. In the lower part then you can see description of the blank node A, and it says that it is a meat of type beef and it weighs 300 units, some integer value. Based on the predicate here, it would be probably in grams. The same thing, but in more compact way or form, can be captured using turtle syntax or N3. And this syntax is very widely used for its readability and syntactic sugar. In other words, some shortcuts how to write certain things. So we can see the prefixes at the top, very compactly written. And then there are the shortcuts that we start with the subject, example Eve. And then we have two predicates. Example is mincing, then some blank node, and example has name Eve as a string. And in the blank node, in the square brackets, we have two more statements about this blank node, that it is the beef meat and that it weighs 300 as integer. Yet another format, trig. You can see that it is very similar to turtle syntax, but it allows subgraphs or name graphs, these quotes with the fourth value. And in this example, you can see two of those. First one is some default graph, so that graph does not have any identifier and contains two triples. And the second one has its own URL as a referent itself, so we could then use this URL to make some description of that resource as well. And the trig format does not somehow restrict the number of subgraphs, so you could have as many subgraphs here as you need. A favorite format in linked data and semantic web is JSON-LD. So it's basically JSON, and LD stands for linked data. And the LD actually means that there are some special fields or attributes inside the objects, and those are denoted by the @ symbol. So we can see that in the @ context, it is possible to specify what terms or vocabulary are you using in the JSON-LD file. And then in the body you can specify the type of the record, so in this case person, and then its fields. So for example name, and then there is my name as a value. And both person and name are defined within the context, so we say from which vocabulary are we using these terms, person and name. And the last one that we have here is RDF-A, which means RDF in attributes. And you can see that this is an HTML fragment, which there is some div container, and then there are some spans. And each of those has some special attributes. So in div, we have this definition that this is about some example book. So this is a subject, and then we have the three properties. title, creator, and date, and each of those has some literal value inside the span. So actually this fragment in HTML contains 3 semantic triples, so some small graph. So now we know how to actually represent RDF and what to do with that. So you can use some data files. You can store RDF datasets as files on your local computer, in cloud, in some storage. And you simply write triples or quotes into a file using some editor. There are various tools for that. And there are also some libraries in different programming languages. There is a short example, but there are many more. And basically for any widely used programming language, you find few libraries that can be used to work with RDF, which means parsing or also serializing RDF, and also some additional things like going through the RDF file in the code, making some queries, etc. Another use case for RDF is to capture some metadata. So describing some data sets. Usually this is part of semantic web, but this can be also used in some files or elsewhere stored. So as a metadata, you can have the record in some website as part of HTML, or for example, to expose RDF from some API. But you can have metadata about some dataset also stored as a file, for example, next to the dataset, which actually does not have to be RDF, but the metadata can be RDF. Metadata can describe, for example, what is the name, what is the author, when the data were created, what was the process, the provenance of the data, etc. For that, it is using usually some common properties from well-defined vocabularies, so the predicates are somewhere defined and well documented. And there is a huge benefit in using RDF for this use case, and it's mainly for its flexibility of adding as many triples and as broad triples as you need to describe a resource, because of course it's resource description framework initially designed to model or create metadata, so this is one of the primary use cases for this technology. Then we discussed files and metadata, but you can store RDF statements or graphs in some specialized databases, and usually those are called triple stores, so storages for semantic triples. They provide additional features which you probably will not achieve easily with files. So for example, import, export, some access control, auditing, and also querying using specialized query language. We will get to some practical example in some later presentation. But to summarize this, it's similar to what you probably know well from relational databases or object databases or document databases. You basically store there something, and then you can efficiently do some operations over that data that you store there. And one of the other main use cases for RDF is of course semantic web. So we've seen in RDF-A, but also JSON-LD, that RDF can be part of websites or web pages. And actually there are two main ways how RDF can be used. So you can have some APIs or some service that does content negotiation using HTTP. So for example, when you are opening some page in your browser, it automatically or primarily says that it prefers HTML to display it to the user, but it is possible to request some other format. So you can, instead of HTML, request RDF, for example, RDF in Turtle or XML, and it will send, instead of HTML, that format if the service supports that. Other option we've seen with RDFA, directly embedding RDF triples in HTML fragments. And this is actually a way how to do these 5-star open data, which is something depicted on these steps. So first there is PDF as 1-star data. So when you have open data or something, you basically get the first star. Then if you have some readable format, some machine readable format, you get 2 stars. If the format is open, the specification of the format is open, it's 3 stars. If you are using resource identifiers inside your data, you get 4 stars. And then if you are linking with other data, you get 5 stars. You can visit the site for more information, which may be useful, especially if you are into semantic web and open data. So to summarize this presentation, RDF is a framework, be careful, not a language, specifying how to describe resources using something called semantic triples, subject, predicate, object. A collection of RDA statements forms a dataset or graph. Nodes, subject and object in a graph, can be reference, literals, or blank nodes. RDF statements can be serialized using different formats, as we've seen, and these formats have different advantages and disadvantages. And finally, RDF statements can be stored in files, databases, or can be part of websites, as well as used for information exchange, for example, in some APIs and web services. So this is everything. And with that, we reach the end of this presentation. Thank you for watching it. And I hope it provided a good overview of RDF basics. And next time we will take a look how to provide some structure or models for RDF statements.